Hello students, this video is in response to questions about the dual effects of increasing atmospheric CO2 on the concentration of atmospheric oxygen. Recall that in photosynthesis, plants use carbon dioxide, water, and light for aerobic processes, and the products are high-energy glucose with oxygen as a byproduct. This process increases atmospheric oxygen. Also recall that during respiration, cells obtain energy by combining glucose and oxygen, resulting in the release of carbon dioxide and water vapor as byproducts. This process decreases oxygen. Photosynthesis, coupled with respiration, is therefore a balanced ecosystem loop where a decrease in CO2 and an increase in oxygen during photosynthesis mirrors an increase in CO2 and a decrease in oxygen during respiration. This exchange on land is nearly a 1-to-1 CO2 oxygen ratio. Recall that CO2 is the greenhouse gas that is predominantly responsible for the enhanced greenhouse effect, global warming, and the resulting global climate change, and that oxygen is not a greenhouse gas and therefore does not play a role in global warming. Now, let's examine the effect of decreasing oxygen as a result of rising CO2. Decreasing atmospheric oxygen is a direct result of the burning of fossil fuel. In the fossil fuel combustion formula, organic matter uses oxygen to produce heat energy with CO2 and water vapor as byproducts. This process decreases oxygen. Observations show that fossil fuel burning increases CO2 in the atmosphere and removes oxygen. As a consequence, oxygen levels have been decreasing steadily over the past 20 years. So we use up oxygen to produce an increase in CO2. Now, let's examine the question of increasing oxygen as a result of rising CO2. As a result of the burning of fossil fuel, plants now have access to an elevated level of CO2. This is called CO2 fertilization, reflected in this image as a bloom in green vegetation. This graph shows the increased biomass production from two different types of CO2 fertilization experimental methods. Plants were fertilized in an enclosure and in free air. With both methods, there was an increase in photosynthesis, producing an increase in biomass production. So, with CO2 fertilization and a ramping up of photosynthesis, more biomass is produced and more oxygen is liberated from water molecules, resulting in an increase in atmospheric oxygen. Now, theoretically, and in isolation of other processes, this process would result in more oxygen molecules in the atmosphere. Recall, however, that photosynthesis does not exist in isolation. The reverse process of respiration is also in play. This set of graphs show observations of oxygen-CO2 ratio from experiments over 3 different forested ecosystems. The observed oxygen-CO2 ratios were virtually indistinguishable from a ratio of 1 over the full diurnal cycle. As a result of the balanced ecosystem loop of photosynthesis and respiration, the net result of CO2 fertilization is no significant change to the concentration of atmospheric oxygen from increased levels of photosynthesis. The overall end result of increasing CO2 concentration on oxygen is a slow reduction in its atmospheric concentration. If you still have questions, please email me and I will be more than happy to set up an individual session to discuss this topic further. However, I hope this was helpful and answered your questions and there is clarity and we have liftoff.